Hello and welcome again to this YouTube channel. So basically, right now, we just try to solve the first differentiation, my first derivative for my y. Okay, these are three examples. Okay, different type of example. But right now, we don't use first principle of differentiation anymore. That one is actually the main idea. What is the formulation or what is the exactly the derivative, but once we already identify the concept of second and tangent line, actually we just focus on the solving part of f or y or whatever function that you have. Actually how to solve it is just a straightforward. You have a few different kind of formulation. There are a few ways to solve it, okay, but we move forward one by one. Okay, this is the first example. Oh, sorry, three simple example to solve it. The first one is just a 3x square, and then based from your formulation, when you want to find dy dx, okay, you just use your formulation. 3 is a constant for your x, just leave it as it is, and then now we play around with your x square. Okay, my formulation mentioned that if I have x to the power of n, I need to put my n at the over here, okay, next to it, and then I put my original x, but now my power is reduced, okay, meaning that I have this. Okay, so once I have this, I have 6x only. All right, so uh, you must you may think, all right, you may think why that is why that is so. This is actually based from the formula, and why they have the formula. Actually, the main idea, if you don't mind doing the first principle of uh differentiation, is a little bit tricky. You have to do all that fx plus h as in the previous example. You will definitely get the same value. Okay, so the formula is being made for you to make it easier for you to solve your differentiation. Okay, that's it, that's the main idea. But if you want to start from scratch, you can always go back to your first principle of differentiation. The answer exactly as how you solve by using this. It's just that the tricky part about using everything use first principle is, one, it takes a lot of your time, and then two, it will complicate your function, especially if your function is involved with a logarithm, exponential function, denominator function, chain rule, chain function, composite function, and so on. Okay, that's why we normally just utilize the formulation of certain on the easiest way for us to solve this. All right, so I hope you get why we have that kind of information. And then if let's say we look at the second question, okay, this one is actually also a simple example. Okay, but this one they start to introduce the composition of uh, 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 addition and also subtraction, okay, within the function. All right, don't worry about the addition and subtraction. You also do the same thing, but now you are doing it one by one according to the function. Okay, in this case, you know x to the power of 7 is just one function. So you do similarly, you have 7 and then x, and then your power now reduced. And then if let's say this is a little bit complicated, you can change this into uh, half, and then x to the power of -1, so it is easier for you to solve. All right, so in that case your half is still half, and then now your power -1 go, you put at the early over here, that's why you have the positive sign, and then now your negative one becomes negative 2, and then at the third function you only have plus 2. Plus 2 is actually, okay, I hope you don't get confused with this. Okay, this one is for this and this one is for this. uh 2 is actually just 2 x to the power 0. Okay, that's why by the end of the day you have 0 over here, but people don't write 0 here, right? Okay, so basically to simplify things, you have 7x to the power of 6 plus 1 over 2x square. All right, so this is your final answer. And then we move on to the third answer. Okay, so this one is a little bit actually, if you if you don't mind expanding, this should be okay, but I recommend if you have the product valuation, I recommend you do it in a product rule kind of situation. Okay, why? Because in the future, once you have the product rule, for example, in a bracket, and then your bracket now have another value, for example, to the power of 3, for example, then you don't get confused anymore. Okay, so I recommend you start with the product rules and do it accordingly. Okay, so how to do just that? Normally we put u. Okay, I introduce another value so that it would be easier for us to solve. Okay, and then in this case my u now is x cube plus 4, and then my, oh sorry, my v now is 3x square minus 2x. And then now once I identify two different variables, okay, in this case my value just becomes this, and then my second value just become this. Okay, okay, and then how to solve this? Okay, I know that by using the concept of product formula, okay, to simplify things, actually I know if I have uv, okay, so my product now becomes only u dv dx, okay, plus v du dx. All right, and then my u is just this, okay, and then my v is just this. Okay, and then my sorry, that one earlier is dv dx, and then my v is 3x square minus 2x, and then my du dx is just 3x square. Okay, once you have this one, then you can simplify and make sure that you have oh sorry, a more beautiful ways to represent this. Okay, so why we have to simplify this? Because we don't want to, for example, in your first term, you already have x to the power of 4, but on your second term, you also have x to the power of 4, but then you separate them together. That does not make sense, right? You have to categorize x together to in its original category. Okay, so that's why I try to expand this again. So, okay, this one I get to x cube. Okay, and then you can do it again as how you normally do. 9x, okay, minus 6x cube. Okay, okay, and then so once you have this, then you can simplify 6 and 9 is just 15. Okay, now you can see why the same thing as I said earlier. You categorize them together. Okay, so you have x cube. It looks a little bit nicer, isn't it? Okay, so see, so this is the dydx that I actually want to obtain. Okay, so I hope you understand the whole concept of writing it slowly and doing it very carefully. Okay, why? Because normally when we are dealing with such formulation, and we are dealing with especially extensive and complicated function, okay, we tend to get distract with formulation, but actually we can do it. It's just that once we get distracted, and then things get out of hand, and then we didn't get what we normally get. All right, so I hope you enjoy this video. I'll see you guys on the next lesson. All the best.